All right, BCA-101, Introduction to Computers. We're on the downswing. It's after spring break. We're on the second half of the term. We get started on networks today. We'll do a few things from Unit 4, multimedia, during the term. I mentioned to the students if they have a good project that involves the technology we've been learning in class, they could substitute that for our last project, Project 6. So we'll see if we come up with any. I'll give you a broad view of what we talked about. Side note, we talked about massive open online courses, the peer review and how those work. We're going to look at some examples of that in this class, probably start on Wednesday. So we have this massive internet, and we talked about how does some information from maybe, in our case here, my iPad, or somebody in the class, their smartphone, or even a PC in 229 connected to the network. We'll meet in 229 on Wednesday and Friday of this week. All right. So these devices connect Wi-Fi to an access point. We'll be talking about an access point, and switches allow us access into a network. For example, this switch here could have PCs connected to it or wireless devices connected to it through an access point. It sends its information to some type, in this case, a routing device, and it decides whether the information goes down here to these servers or goes out through the firewall to another routing device that decides, is it something on the other side of campus, actually in the same building, just on the end, the IST area, or if it's something that has to go out to the internet. And then, of course, the internet moves the traffic through to your destination, which could be Google somewhere. All right. So in order for these things to communicate, we have to have some rules for transmission. Those are called protocols. How many bits we can send is the bandwidth. For example, a lot of Wi-Fis are 54 million bits per second, and that actually becomes less as you add devices on to an access point. And then we have media. We talked about media before, and we'll be emphasizing a few things with that, whether you send it through the air, sending it through a wire, or sending it through fiber optics. So in this case, we send the message through the air. We use a certain protocol to get it from the iPad to the access point. The access point actually uses something known as Ethernet to get it through the switch and to this router. This router then uses Ethernet also to get it through the firewall to the other router, and then this router uses some wide area protocol to get it out to the internet. And the internet uses TCP/IP to move it through the internet. Okay? And it occurs everywhere that way. All right. So we have devices. We have modems that allow the information to be put onto the wire. NIC cards. We have radios built right into the like your phone and your iPad. Then we have switches and access points that allow us access into the network. And then we have routers that route the traffic between networks. We'll explain that a little more thoroughly later on. So we're routing the traffic. That happens on the internet. Traffic gets routed. And the last thing we talked about were addresses. You have these IP addresses, and we gave an example here at NIACC, 207.165.226.182, where you might have 10, 200, 140, 31. So your device can have an IP address. It will have an IP address if you're connecting. And then it also has a physical address. And we looked at some examples of live ones here using an app on the iPad. So here's what happens. Your device has a physical address and an IP address. When it sends something out to the internet, it has the IP address of the device out on the internet. So let's say you have an IP for Google. You actually use the name, but it gets converted to an IP address. So that goes then to this device, and this device connects to the switch. The switch keeps track of the physical address here. It goes to some routing device, which then matches up the physical address and the IP address. The physical address, this MAC address, then can be dropped once packets are routed through the network. And then when they go out to the internet, they use the IP addresses to move through the internet. And then the information comes back from Google. It has an IBP that sends it back to the ICN. The ICN sends it into the network. This router decides if it belongs over here or if it belongs in this part of the network. This router can route it to the switch, but before it sends it to the switch, it's going to put the MAC address back on there, kind of like the person's name. Sends it to the switch sees the MAC address, sends it out, and it goes out to the particular device. Every device in the world has a unique MAC address. Every device in the world that's communicating on the network gets an IP address, and that could vary from time to time. All right? The interesting thing then that happens, you have your internal private address on your device, but when it goes through, like here at NIACC firewall, it gets converted to a public address that can be used out on the internet. That address used on the internet to send it back here. The firewall then keeps track of those using port numbers with the addresses, converts it back to this address. Then when it hits a routing device, that adds to it the MAC address, and matches them up, and then the switch gets it to the right device. So, that is it for today.